Cool. How many of you have used Clojure or know what Clojure is? Some of you. Okay. How many of you are testers, by the way, who do testing? Oh, oh, okay. Cool. So, what is the problem, right? So, testing real-world stateful business logic is very hard. There are a lot of cases to worry about. There are a lot of combinations, right? So, for example, here is the microwave oven state machine diagram, and as you can see, there is a lot of transitions that can happen. So, and it has inherent state built into it, which needs to be tested, right? Even if you have a functional programming language or any of that sort, you still need to test against a certain state, right? And it becomes difficult to enumerate all possible combinations, right? How many times should you set the timer back? Till you may not encounter a bug if you set the timer once, but the third time there might be a bug, right? And because if you try to enumerate all possible combinations, the test becomes really unreadable, and they become really hard to reason and what this test is really about. So what I'm proposing is that using DSL is a way of writing tests which can solve this problem. So what is a DSL? A DSL is a domain-specific language, which is it's like a programming language designed specifically to address solutions to problems in a specific domain. So this is not a general-purpose language. It's targeted towards the domain. So let's take a real example of that. So at HelpShift, we are making embeddable support desk for native apps. So as a developer, you can take our SDK, put it inside. Each domain can have several apps. Clash of Clans, Boom Beach, and Ghana has their Ghana app. Each app can have several sections. Each section can have several FAQs. And each FAQ can have several translations in several languages, right? So here is a Ghana.com FAQ page. How many of you know Ghana.com? Yeah, cool. So that's the domain. This is the app. That's the FAQ section. Within that section, these are the available FAQs, which can be searched by the customers. And here's how you can create an FAQ on our dashboard. Here's you can add a title, a body, and some metadata like whether the FAQ is available or not. And there are two published meta. So one is that globally whether this FAQ is available, and each translation can separately be turned on and off. And I need to talk about that because it's important later. So there is a problem, right, in our system, which we were trying to solve, is that currently we could not have one FAQ common across several apps. If you have, say, a privacy policy, you need to create those privacy policy again for a second or a third app. So we needed to solve this, but there was a constraint that the customers wanted only the content to be shared, but not the whole meta. They didn't want to share all the meta of whether this FAQ is available or not that FAQ available. So we introduced a feature called linked FAQ. So here is an example of that. So there is one app which has a section called general, and within that there is an FAQ which has this translation with that body and title, and there's some metadata. Then there is another app with another section, and we want to sync FAQ1 to app2. So this will create another FAQ with the same translations as the body. And if I update one body, the backend will automatically update that. So this was the feature that we were supposed to test, and it quickly became really hard to try different kind of combinations. What happens if I delete one FAQ? Does that get deleted or not? Should it get deleted or not? What happens if the app is deleted? What happens if the section is deleted? What happens if I update this one? Does that get updated? What happens if I update that one? What if there are 5 different apps, and so on and so forth, right? So how many combinations would you try? It's really hard to know that. So here's an example test case. So for example, I would like to add one app with only English language, then add another app, then add first FAQ under the first app, then link first FAQ to second app to create second FAQ. Then I would like to test whether the translations of both these FAQs match, right? Then I would like to update the English title. Then I would like to check again whether the content is being actually synced and updated to the second FAQ as well. Then I would like to delete the FAQ and then check whether FAQ is actually deleted in the database. then I would actually make sure that second FAQ is still remaining intact. So can anyone see a pattern here? Anyone? There are two different things that are happening, which are complected, which they should not be. That one is the simulation part, where I need to do something, and one is the verification part. Normally in a test, they're complected. I am proposing that they need not be. They can be decoupled into two different things, and the DSL can allow you to do that. Let's see how. So part of each action, what are the paths? So say for example, this is an action that I would like to do in my test. I would like to add app 1 with only English language. So first part is, there is a type of action that I would like to do, adding an app. Then there is a certain name that I'm referring to, that's app 1. But this app 1 is something that I am referring to. Internally it will be created some ID which the system will refer, like ID 1, 2, 3, 4, 5. But that's a runtime value that I don't know of. So I'm referring it to in a way that I can understand in my test. Then there is an argument to that I would like to have only English language in this app. Maybe I would like Spanish, maybe I would like some Hindi language as well. Then there is a certain expected result as per my spec, as per my understanding, as per my model. And there is an actual result, which comes from the database, which comes from the state. So there are 5 paths to each action that needs to be understood. So what if we could express this action that we need to do in terms of data? So here we are going to use something called as def record. It's something like basically like a class, but without inherently having functionality built into it, right? Just think of it as a hash map. It's just a hash map of this is the constructor, and just those are the arguments to this constructor. So I'm saying there is an add app which will have app 1, and that's the hash map configuration. Does this make sense? Okay. So here is the similar set of test cases, but in terms of data, right? So here I'm adding an app, then I'm adding one FAQ, but here I'm referring to the name. So app 1 is being referred later. So I'm saying when you added that app, call it app 1, and when you want to add an FAQ, call it FAQ 1, but add it to app 1, and so on and so forth. So this allows me to say the test in exactly the way I would express it to a developer. Add one FAQ, then create one app, within that app create another FAQ. It's similar, but this is executable, right? So, but to run this series of action, you need a certain context to maintain, because it's kind of like a programming language, right? So to have that context, you need 3 parts. One is the environment. So the environment contains, when I say app 1, I actually, internally it will mean the ID of that app, which is 970, right? So this is a giant hash map. There are 3 parts to it: environment. Within the environment, there is apps. Within the apps, there is app 1, app 2, whatever it may be, depending on what actions you take. And then the app ID of the actually what I need to refer to actually do something. Then second is latest simulated state. So after each action, what is the current expected state of the system, from my understanding? And then there is a log of after each action taken, I want to log what happened for that action. So if I added an FAQ, what was the simulated state at that point in time? What was actually the state of the Elasticsearch, Mongo, whatever, and so on and so forth, right? So you keep adding to that log history after each action. Make sense? Okay. So let's just have a high level overview of the DSL. So we'll start with an initial context. We'll take the first action. We'll pass it to the run DSL. Then you will get an updated context with the updated environment, updated log, and updated simulated state. Then you'll pass it again back to run DSL with the second action. Again give it to run DSL. You will get another updated context after second action. And then so on and so forth till you are exhausted with all the actions. So let's take a more concrete example of that. So here, that's the initial context where the environment is empty hash map. Latest simulated state is empty because there is no state right now. And the log is just a list of empty list right now. And then you start with one action that I would like to add app, call it app1 with language configuration nil. It's saying nil because by default we always have English language. You give both to run DSL function, and you get an updated environment back, the updated context back, which has the environment apps with app1 with whatever ID, and some log and some simulated state, right? Now you pass it back again, recurse back, and then you get the second action, and you again give it to the run DSL, and again it adds. So this time the action was add app2, here you have add app2 in the environment, and then you keep going. But what happens inside the run DSL function? So you dispatch on each action, right? What you need to do is first update the variables in actions to its binding. So when I say app1 in my argument, I need to understand when I try to add an FAQ, what this app1 really means. What is the ID of that? And I need to put that back in the action. I'll give a real example of that. And then you actually need to call the actual function which will do the side effect, which is part of your actual implementation, which will be done by the run action function. And then there is what the result of that, you need to use that to bind the result back into the environment. So when I create an add app, once the app is created, whatever app1 I'm calling, I need to add that back into the environment and say when in future when you say app1, I mean this ID, right? Then you would like to update the latest simulated state that after doing this action, this is what I expect the state to be. And then what actually was the state in the DB? There is no verification at that point. You just collect history. Normally in unit testing or any kind of testing, you do something and then you immediately assert. Here the idea is you don't assert immediately. You store what happens and what you expected. And later, all you just need to go through it and just verify that. And then you continue with the next action and then keep going. So each def record action implements a certain protocol, a DSL protocol, to be able to do this. So those actions that we saw, those 5 actions, are each part of a protocol called DSL protocol. So this allows me to add behavior to each data. We'll see an example of that. So here is a def record, add app, where once I am adding the app, I want to call it app1 with the argument lang config nil. I will dispatch on the actual implementation of this and called resolve action vars. Here there is no var, there is no variable that I need to refer because I will be creating an app1, but there is no variable or any previous variable that I'm using. So it just returns as it is. Then I want to run the action. So to add an app, I need to call some internal implementation of add app with the argument lang's config nil. That will return me an ID, which using that I will update the environment. So in the environment, I'm adding app1, and that ID is 970. This ID 970 I got from run action, which is the side effect that happened. And that run action buying is to signify that there is some side effect, right? Then you would like to update the latest simulated state. In my test, I don't care about apps, I care about FAQs, right? So I just say, I don't care. I won't say anything about it. Similarly, for update log, I don't care. I just return as it is. Next time, I would like to add another app. I dispatch again on add app, call the resolve action vars. There is nothing to resolve. Run action, get add app2, add it to the environment. You get a new ID for that. Update latest simulated state, nothing to do, and then you continue. Now, here's the interesting part. Now I would like to add an FAQ, call it FAQ1 to app1, which was already created previously. So I would dispatch on add FAQ implementation for resolve action vars. So here the var is app1. What is app1? I don't know. So I would look into the environment, see what app1 refers to, which is app ID 970, put it back inside that map which I need to put it, because that will be used by the actual implementation. Am I making sense? Okay. And then I will actually call run action with add FAQ for app ID 970. I cannot call app ID with app1 because that app1 is meaningless at runtime. And then I'll actually get an FAQ ID back, which I will update the environment that if from now on, if you call FAQ1, I mean that FAQ ID 112, right? And then I would like to update the latest simulated state. So there is some model that if after this action, this is what I expect the state to be, and I add it to latest simulated state. And then I fetch whatever is actually there in Elasticsearch, whatever is actually there in Mongo, or whatever database that you care about. Whatever that actual implementation has done, you store that as well. And you store what is the snapshot of that latest simulated state. So that gives you a snapshot history of after each action and whatever action taken. So then I can just run through the whole log and figure out at what point in time what failed. So there is no verification right now. Once you run through the actions, you do verification after that. So verification is straightforward. You compare the result of first action of what I generated, what I expected it to be, and what was there actually in the DB. If they match, you pass for that first action. But say the second action, I got something like this, but actually the title did not get updated. I can just immediately say, second action failed, this is what you expected, this is what you got, and this is what you tried. And this can be done later. I can store this whole log history in a database, look at other things, anything. So let's look at a real example. So here I'm saying run DSL is the function that will take. Domain is what what site I want to add an app to. And then I'm saying add app1 and call it language configuration is nil. Let's see what it returns. So it returns a context where apps with app1, which has app ID this, and there is a section ID. And latest simulated state is empty, and log is empty because I don't care about it. Let's take a slightly bigger example. So here I'm adding an app, and then I'm adding an FAQ to that app. It returned a huge output. Let's just see what all it has. So it has the environment, a latest simulated state, and a log, like we discussed. So let's only look at the environment. So it has apps, it has an app ID, and that there is an FAQ. FAQ1 refers to that FAQ ID. And it also says that app1 has this FAQ ID. It's a set, basically, right? So here I'm saying, that add an app, then add an FAQ to that app, then add another app, link FAQ1 to app2, and call it FAQ to app FAQ2 here. Link FAQ1, call it to FAQ2, and to the app2. Then I would like to update that FAQ2 with the new title and the new body. And then let's just not delete the FAQ for now, just to see. got some output back. So it's too small. So here I got this new title, the new body. Right. So these two, and you can see here linked apps. This FAQ is linked to another app. So how is this being done? So let's first look at the DSL. So here is the protocol. This is the protocol. All it says is these are the 5 functions you need to implement. These are abstractions, right? So there is no implement. It's like interfaces in Java. There is no implementation in this. All you have to say is to implement this protocol, you need to implement these 5 functions for any data, for any def record. So here, add app. Here it's saying this def record takes an app var and an app args, and it implements this DSL protocol. And here is my implementation of that. So in this resolve action vars, I just return the action back. I don't do anything with it, which is what we saw. It was not resolving any vars because that was not required. In run action, I'm actually calling it an actual implementation of adding an app with whatever app arguments that I need to pass it to. Am I making sense? Okay. And then similarly, you need to have an update environment, update latest simulated state, and then an updated log. Similarly for add FAQ, here I need to resolve the action var, so I take the action in the context. From the environment, I get the app ID back, I get the section ID, put it back into the FAQ config, and then create a new context, a new action, sorry. This is creating their new action back. But how is this being glued together? And there is a def record for context as well. So here is the context, that is environment, latest simulated state, and a log. That's it. It's just a simple hash map. But how is this being glued together is this. So there is a run DSL function. You can pass it a domain and an action, and it will recursively call itself back with an empty context. So here I'm creating an empty context with an environment, log state, and a log and a latest simulated state as an empty thing. Then I get it, come back here, it just makes sure that whatever you have passed to it is the right thing by doing some pre-checks that everything satisfies a DSL protocol, all actions. Then you check whether context is an instance of context, whether it has this key called latest simulated state, it has a key called environment, and whether log is a vector, and so on. So then within this, I check if there is a sequence of actions are there, then take out the first action, resolve that action, and get a new resolved action. Then run that action with the resolved action. You will get action result. Then here I will pass this context, and this thread macro will pass it to the last as a last argument to each function as a result of that. So update environment which will have the result action and the action result, and this new context, what that will return an updated context which will get passed to this, which will get passed to this. Finally, you have a new context after running the action, and you run the DSL again recursively with the rest of the actions left with the new context. That's the key. You just need to recurse, pass the environment around, and keep adding to whatever you want, and keep updating the environment. That's it. So I'll just run a test. So here, for readability, I've also been printing what actually happened. So here it's saying action taken is this, and then I print the diff of what I actually expected and what I actually got. And there are three parts to that. Something that is only in actual, something that is only in expected, and what is common. So if this 2 is nil, then it has passed, that particular action, because there is no difference between them. So this is common, then it has passed. So here it's saying common to both is this, for Elasticsearch data, and so on. Then I can, so this allows me, so this is a very important step in my opinion, because sometimes what can happen is, there is a bug and you have simulated it in a very wrong way. So what happens is it can return nil, and there is actually a nil, and you might get nil equals to nil, and then you say passed. But actually it's not really passed. So you need to have some kind of inspection of what this dynamically is being generated is actually what you really wanted to. I have been bitten by that, so that's the reason why I've added logs for that. And then you can see that it says pass 2, test 1, no errors, no failures. Any questions so far? Okay. So what are the approaches that we can take to verify something like this? Well, we can so normally what we do in our normal unit test is that we have hard-coded actions and hard-coded expected output. This is what I'll do, this is what I'll expect. But it limits the amount of combinations that you can try. You can have maybe 5 or 6 of them, right? It becomes too cumbersome if you really want to try everything. Then there is actions being simulated and expected output is hard-coded. Say for example, I do these 5 actions and I know that number of FAQs will always be 5. I don't care about the result, I just know the count. I can hard-code that, right? And then this simulated and expected output is generated, which is the approach that I just showed you. So there is a simulated set of actions that I take, and there is a model that will tell me what I expect it to happen. And then I can use it to verify. But there is another level that we can go into using this, which is we generate everything. We generate the actions and we generate the output as well. So what are the advantages and disadvantages of both? If you have hard-coded actions and hard-coded expected output, it requires no knowledge to understand. Any newcomer tester or even a developer can come and just read your code, right? And anyone can edit them. And there are it's very hard to get false negatives because you can really read exactly what is happening. But it becomes very cumbersome to enumerate them, and modification is hard. So this is a good fit when the system to test is not so critical, and it's not so big, it's not complicated enough that I can enumerate them easily. Then simulated list of action and hard-coded final expected output, where output is hard-coded, but you're still simulating. So it's slightly better. It becomes more readable because it's like a documentation kind of, right? And it's very, one other great thing about this, I can share it with the dev. I don't have to create a Jira ticket which describes what needs to be done. So I've done that. I used to just share the code. Just run this, you will get the expected failure case. And they used to run it, keep running it till it fails. And when they fixed it, just run it again, they know that it's fixed, right? That was a great win in my opinion. But the problem is that you need to maintain this DSL. You need to tell how to write this DSL, and it can become a problem, right? And expected output may have some runtime values like FAQ IDs which you cannot hard code. So that can become a problem. So that can be solved by having generating the expected output. Because if you have that, there is no runtime, you can even work with the runtime values. But there can be false negatives if your model is also incorrect and the implementation is also incorrect. In the exact same way, you may both miss out on some certain bugs, right? And then there is generated actions and generated expected output. So one of the great advantages of this is you can generate large number of tests and you can generate large number of combinations. And one possibility you can run into is that if I generate, say, 100 action test case and it fails, I don't know what exactly failed. What was the failure? Do I really need 100 actions to do this? Or is there a smaller shrinked case which will still simulate this bug. So there is a way out. There is something called as tests.check, which will allow you to shrink your output into a smaller test case, and it becomes really great. But again, it becomes hard. You need to require the knowledge of understanding how to write this. So let's look at example of this. So we had a feature called issue audit trail. So basically we have another feature called issues, and we wanted to log exactly what is happening by the agents who are replying or the customers who are applying on that issue. So it maintains a log of who took an action, what action they took, and we need to understand what kind of users we have. So at HelpShift we have app user, the customer who's using the app. Then there are support users, and even in support users we have two types, agents and admins. And what kind of actions they can take? Well, app users can create an issue, reply to an issue, and admins and agents can create issue, reply to an issue, resolve some issues, edit tags. So they have certain more actions that they can take, right? So here is an example of such an issue. Here is an app user who has said, hey, I have an issue. And here is an admin who has replied to that. And here is another agent who has replied to that issue. So there are two things here, issue audit logs. These two are the issue audit logs that we are adding, and these are just messages, right? Normal messages that are being sent, and then we are interleaving what audit log happened. Like Mayank plus Mayank log added some tag called game, like that, right? And here, when this issue was resolved, here we add a log that this issue was resolved by this agent. This is useful in debugging. This is useful when, say, you have a customer like Supercell who have like 500 agents, right? And they are like, who resolved this issue? I want to know. Instead of going back to database and figuring out for them, they can just look at this. So this was a critical system. We needed to get it right, and they wanted a certain order of audit logs to happen. They didn't wanted logs to be separated from the issue. They wanted it to be interleaved. And we can't have logs being dropped, because if logs are dropped, it's a problem. So this, and there can be any number of messages. I don't know how many to test, right? So this is a hard problem to solve, and you can't do this with just unit testing. So we went through this route. So I'll first demo this feature. So to generate actions, you need to have a certain kind of finite state machine of your domain itself. That if I start from this action, what can I do next and what can I do next? So in this case, when I start, I can create an issue, and only the user can create an issue with these arguments. Here, this thing is just a vector of three things. What kind of user it is, here in case is the app user, what kind of action they are taking, and what are the arguments to that. So this is slightly different. This is using multi-methods instead of protocols, but the idea is pretty much the same. So then when I start, I can go into a new issue. Oh, so I should explain this first. Yeah. So in this map, basically it says all the left keys are from transitions. Within that, there can be several transitions, and to go into that transition, there can be several actions for that. So for example, if I want to go from transition 1 to transition 1, I can have action 1 to n to do that. So the algorithm, what it does is it starts from whatever transition, randomly picks any transition, and to go into that, randomly picks any of those actions. This need not be random. You can have some kind of weights attached to each action and say, it's very likely from transition 1 to transition 2, action 2 is taken 80% of the time. That depends on your model. It can be done. So here I'm saying, when I start, I need to go into new issue. To go into new issue, there is only one action called user creating an action. Once I go into new issue, here, there are three states that I can be in. I can still be in new issue, I can go into in progress issue of that state, or I can be resolved. To be resolved, either the agent can reply as resolved message, or the support can change the status directly as resolved, and so on. So say for example, I start with new issue, it will pick that. Then from new issue, it will randomly pick one of these three states. Whatever state it picks, say new issue, it will pick randomly one of those three actions, and then so on. Right? So this will allow me to randomly combine actions and generate expected output without having to know what I'll be generating. So let's run it and see how it's done. So I'm saying create on this domain, create one issue with 5 actions. I'll add a sleep so that it's easy to see. Here you can see it randomly added some actions, and when I try to look at the log activity of it, here it's saying this person reopened the issue, here some actions were taken, right? And this is random. And if let's look at a bigger example. Let's say 30. So here you can see it added way more actions to it, right? And this is, I don't even know what this issue is, what all it's done. But this is just simulation. Where is the test? So here I'm saying create an action, one issue with 5 actions, and then check whether the trails are tested and messages that are being rendered on the screen are also correct. So when I run this, I'm printing this. So there are 2 parts to it. One is that here it's saying this is what I expected the trails to be, and this is what I got. So this has passed. And then what is being rendered, I expected 7 messages to come. I expected 7 messages to be there, and I actually got 7. Here is the table of what I actually expected and what I actually got. That's too small, I guess. Yeah. So here is and it's showing the table, this count. This count is important, I'll show you why. So if I run this, even if I run this again, no matter how many times, it always passes. But what if I increase the number of messages? So right now I'm only, oops. I missed just a sec. So here from 5 actions, I'll make it 10. It passed, so I can see here messages, all those messages have matched. Let me remove that sleep. Let me make it 20. Something has failed. So it did pass up till now, but it failed, I don't know why, right? And it's saying, except for the first message, everything else is not matching. So if we really look at it, I don't know if we can, yeah, it's too big. But if we really look at it, basically, the order, it's an ordering problem. And it happens on a very, very particular specific case, right? Let me reduce this to say 15. So as you can see, this allows me to kind of dynamically change, and again it failed, right? Here you can see true, 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 and false. Let's see false, 23, okay. And here it failed again, which is 15. Interestingly, we paginate older messages after 15 messages. This can be related. And turns out it is. So this is the original input data that we got for edge case as an example, right? And this is doing a lot of stuff. It's hard for me to understand what part is actually important, right? So the DSL, I can either write a function which will do this simplifying of the test case, or I can do it even by hand. So after doing it by hand, I realized this is simple enough. But the problem is, this bug only happens for older messages after 15 messages are there. So there has to be at least 15 messages. Within that, it will never fail. That is why if we had a count of 5 or 10 actions, it just passes always. But after 15 messages, it may fail only if the audit trail happens to be on the page, at the border of pagination. If it is before or after that, it will still be fine. Why? Because there are some audit trails which will have 2 messages combined. And if that message gets stopped at the pagination, that message will come again at the second pagination. And that is why you will have the same audit trail twice. So this bug was really hard to figure out, and it took us quite a while after we have done a lot of exhaustive testing that we found this bug. Does this make sense? So what are the advantages of writing a DSL? So it helps in finding really, really hard to find bugs. For example, we found duplicate issue messages where the order needs to be just right to find it. Finding ordering bugs is something that we found. And it increased the productivity of a developer and tester because I could share this code and directly say, this is how you can reproduce the bug. The disadvantage is that it adds a lot of high cost in maintaining the DSL. Right now, I am the only person who understands this DSL. So that's a problem. If you have a big team like 5 or 10 people, you need to teach them how to use this. And if your another problem is that what I face is if your DSL is just data, if you make some mistake, you won't get compilation error because it's just data. Unless it's actually being evaluated by a function, you won't get any error. That can be a problem. And you have to educate your team about how to use this DSL. So in conclusion, DSL can be used for workflows for testing. Separation, I think that's the key. Separating simulation versus verification. Store your results, don't verify them immediately. You can store it in DB, store it in memory, do whatever, but don't verify it immediately. And then you can do all kinds of things with it. And it's a step towards generative testing. If your system is really critical, if you really need to test all possible combinations, then this can be really useful. Here are some resources. So Martin Fowler is a very well-known person in DSL community, and there is DSLs in Action written by Debashish Ghosh. It's an excellent book, and there are some other links for that. Thank you. Any questions? Yeah. Yes. But quick check is a step ahead because it's more of property-based testing. Sometimes it's really hard to define a property, right? And this is kind of in between where unit testing and generative testing, where I don't know the property, but I can model myself, and I'll explain it in step by step what needs to be done. So this can be also useful in, say, for example, there is a bug that was found by QuickCheck, and I have fixed it. Now I would like to make sure it never comes back again, because QuickCheck may or may not check that again, right? So I'll express that in my DSL, and I'll make sure it's always catched. Yeah. Any other questions? Okay, thank you.